How do you calculate power for Python hypothesis tests? Imagine you're about to run an experiment and want to be sure you'll catch real effects if they exist. That's where understanding how to calculate the power of your hypothesis test comes in. Power is the chance that your test will correctly reject the null hypothesis when the alternative is true. It's like a safety net to make sure your study can detect meaningful differences. To figure out the power in Python, you need to know a few key things. First is the effect size, which measures how big the difference or effect you're trying to detect really is. For example, if you're comparing to groups, Cohen's d is a common effect size. It's calculated by taking the difference between the two group means and dividing it by the pooled standard deviation. Next is the sample size, which is how many observations or participants you have. Larger sample sizes generally increase the power. Then there's the significance level, often called alpha, which is usually set at 0.5. This is the threshold for deciding whether your results are statistically significant. The last piece is the power itself, which you want to be at least 0.8, meaning an 80% chance of catching a real effect. Now, choosing the right test depends on your data. If you're comparing to means, a t-test is common. For more than to groups, you might use an analysis of variance. For categorical data, chi-square tests work well. Python has great libraries like StatsModel that help with power calculations. For example, the StatsModel library has a class called t-test_in_power4 to sample t-tests. You can use it to find out how many samples you need, or to see what power you have with your current sample size. Here's how it works in practice. First, you estimate the effect size from previous studies or pilot data. Then, you set your alpha at 0.5 and your desired power at 0.8. Using the t-test_in_power class, you can solve for the sample size needed to reach that power. For example, if your effect size is 0.5, alpha is 0.5, and you want 80% power, the code will tell you how many participants you need in each group. You can also do the reverse. If you already have a fixed sample size, you can calculate the actual power of your test. Just plug in your effect size, sample size, and alpha, and the library will give you the probability of detecting a true effect. This is super helpful for planning your experiments or understanding the reliability of your results. For other tests like analysis of variance or chi-square, StatsModel offers similar functions, or you can run simulations to estimate power. The key is to specify your effect size, sample size, significance level, and test type, then use these tools to get your answer. This process helps you design better experiments and interpret your results with confidence. So, next time you're planning a hypothesis test in Python, remember that calculating the power is a vital step to making sure your study can truly detect what you're looking for.